Hello, my name is Rafał and I'm part of the SimBa rocket team from Gdansk University of Technology. Our team number is 33 and we are competing in the 10K SRAD hybrid liquid category with our one-stage rocket that we refer to as R5. This is our first time competing in Spaceport America Cup, as last year's edition was cancelled. The outer parameters of our rocket are the diameter of 15 centimeters and the length of 4.4 meters, with an engine that generates a total impulse over 15 kilonewton seconds. Our team consists of 6 divisions: the recovery, the engine, mechanics and avionics, electronics, payload, and business.
As in many other rockets, our mission concept of operation starts with the ignition phase. The rocket goes through the boost phase and slowly starts to lose speed. At apogee, the first recovery event takes place. The main reefed parachute is deployed, and the rocket starts to fall with a decent speed of 25 meters per second. At 1148 feet, the parachute is unreefed to its full diameter. After that, the rocket safely comes back to Earth with a second decent speed of around 7.5 meters per second.
I'm Krzysztof and I am SimBa team leader and avionics team coordinator. We have 4 people working on electronics, hardware and software. Our flight computer is based on open source drone controller Pixel. We decided to use this solution as framework to develop the rocket control system. We are able to monitor various rocket state parameters: orientation, rotation speed, acceleration, position and velocity, auxiliary pressure and temperature. The onboard computer checks all sensors and subsystems, communicating rocket readiness for launch. When the rocket is armed and the operator sends a signal, the computer executes the automatic launch and flight sequence. To properly test our software, control algorithm and flight sequence, we developed a 3D simulation of rocket flight. We use the gazebo simulation, which is connected to flight computer software. Here is a video of how this simulation works.
I'm Norbert. I'm responsible for hunting down our rockets and after that processing their telemetry. We are using 2 radios on board our rocket. First is well integrated with our Pixel solution and is used for command and control along with telemetry capture. Second one is Altusmetrum telemetry. We use its telemetry and APRS. We proved that we are able to keep stable radio links during the whole duration of the flight until touchdown. Then we use last known position and APRS for final recovery.
Before we started designing the recovery system, we thought of the things that we want to do and the things that we can do. Our previous recovery system were based on nitrocellulose, but due to the law of both Poland and the USA, and having in mind that we need to transport everything by plane, we decided that we can use neither nitrocellulose or black powder. We choose to design CO2 canisters piercing system based on loaded spring released by the servo. As for our dual event recovery, we choose reefed parachute. This type of reefing is called vent reefing and will be done by pulling the vent line attached to the center of the parachute down. To release the line, we designed a line cutter device that will burn through the line connected to the reefing line.
My name is Mateusz. My name is Victor, and we are the founders of propulsion team in SimLE. Our work began in late 2019, when our team was admitted to Spaceport America Cup 2020.
We started to develop our first rocket and we recognized that we don't have enough workforce, so we decided to expand our team from 2 to 6 people.
In preparation for Spaceport America Cup 2020, we began work at our first rocket engine with help of Polish Rocketry Association and Space Forest Company. Then we learned how to design and build our high-pressure tanks for our oxidizer.
Previously, we learned how to design part of our rocket in CAD environment. Now we have 2 members focused only on CFD analysis and they design our rocket nozzle.
Our work currently consists of developing a zero-dimensional simulation of phenomena happening in combustion chamber and making our parts in our machine workshop.
Hello, my name is Michael. I'm a payload team leader I will show you our payload. It consists of 3 experiments. Our experiment is closed in a 3D printer plastic case. First stage, starting from the bottom, is our radiation shield made of silicon matrix mixed with bismuth oxide and cerium oxide. This is first layer. The second layer is also made of silicon matrix, but with addition of boron nitride and boron carbide. Next stage, we will have muon detector. This is scintillation detector, which purpose is to measure muon intensity. This is a replica of detector made by MIT and NCBO in Poland. When muon pass through the scintillator, it emits a photon, which is detected by a SIP. A SIP is a silicon photomultiplier. It's a very sensitive device that could measure some single photons. Data will be collected on micro SD card, fixed in Arduino Nano. In the next stage, we have our last experiment, neutron detectors. We use proportional counters from Soviet Union. Neutrons don't have any charge. If we want to count them, we must use moderation layer. It must be a material made of large amount of hydrogen atom. For this purpose, we use paraffin. We place our detectors under the layer of paraffin. In the most upper stage, we have electronic for all detectors and 2 lithium polymer batteries that will power our detectors. Our functional payload have weight of 3 kilograms. To fill the condition, we use 1 kilogram of additional mass.